flux due to a charge through a small surface. Let's talk about only small surface right now, which subtends solid angle d omega at q. Okay? Okay. Very small surface. So d phi is in total integral E dot ds. Correct. But here we're talking about very small flux. So here, will you be okay if I write d phi? Okay. Okay. Fair enough. So d phi will be E dot ds. Are you convinced with that? Yes. Here we are convinced with that. Good. Remember, this is not the total flux produced, because if you draw lines of force, okay, let me give you a picture. If you ask me, sir, what is actually the flux here? The flux here is actually the number of lines of forces, relative quantity of lines of forces going through only the surface. Lines of force go everywhere in space, but through that surface, if you quantify, it is, can you please give me the field value? Let the distance be r, sir. Kq by r square. Sir, the angle between the area vector and radius vector happens to be same. Good. Angle 0, cos 0, 1. Perfect. So kq r square into ds, sir. Sure, na? Sure. Okay. Or d phi is equal to, can I write k 1 upon 4 pi epsilon naught? Yes, you can write. Okay. Can I keep q as it is? Yes, you can do that. And can I put your r square below ds? Of course you can do that. Good. What is the area in this case? When the area vector is along the radius, what is area upon r square? Area upon r square is, oh, the solid angle d omega. What did I just get? I got, here, what I got is the flux produced by the point charge passing through the surface ds, which is subtending an angle d omega at the charge. Is that part clear? Clear. Obviously, if the surface size changes, the value of flux through it will also change. Are you ready to change the size? Absolutely. Good. What is the best thing you can do? Make it complete. Complete means what? Sir, sphere. Not necessarily. Not necessarily. Any close point, na? Oh yeah. Oh yeah. So unitary method. Oh yes. If the solid angle is complete. Oh, I got it, sir. I got it. Sure, na? Sure. You are saying it will come out to be q upon 4 pi epsilon naught into 4 pi. Absolutely. Q by epsilon naught. Very good. Total flux, phi total, through surface area. Whose surface area? Of a volume. Through surface area of a volume. Produced by, who produced this flux, by the way? By a charge inside. Can I say it's called enclosed charge? Yes. Is q by epsilon naught. Agreed or not? Now I'm about to do some magic. Agreed? Agreed, sir. Isn't everything produced by charge q also going through the surface? Correct. So how about I cut the statement short and make it another statement? What is that? What is that? What is that total flux produced by a charge? Nothing. No, nothing. Just simple question. What is the value of total flux produced by a charge? Q by epsilon naught. Because whatever is produced here goes through the surface. Now. So you learned two things. What is it, sir? First, total flux through the surface of a volume produced by enclosed charge is what? Q by epsilon naught. Second thing what you learned is total flux by a charge itself is in totality Q by epsilon naught. Perfect. Now you guessed it right. What's about to happen? What's about to happen, sir? If this charge is outside and I ask you the flux through this surface now, it's like saying how much illumination will the inside of this surface receive if the bulb is outside and then surface is opaque. You guessed it right, 0. But if you want, I can give you a math answer also. How? Q upon 4 pi epsilon naught into 0. Because solid angle subtended by any closed volume for an outside point is 0.